Hey, the topic I want to address here is solubility rules. Solubility, if something will dissolve in water. And if it does dissolve in water and it's a salt, it will be an electrolyte. So, conducting of electrical current, kind of a big thing in chemistry and biology and measuring transport of electrons. So, you know that salt water conducts electricity, but did you know that sugar water does not conduct electricity, or alcohol water does not conduct? But any salt that dissolves in water will have ions that can transport the electrical current. Chihuahua, let's see. Oh, yeah, here we go. I thought my program wasn't responding for a second. It wasn't, but here we go. Strong electrolytes, strong acids and strong bases, and soluble salts, salts that dissolve in water. We'll talk a lot more about strong acids and strong bases soon. Weak electrolytes, like the weak acids and weak bases, and the salts that only dissolve in water a little bit. And the non-electrolytes, the molecules that don't break up into ions at all. Which of these would be the worst electrolyte? Well, worst electrolyte. There's a strong acid, that's not going to work. There's a weak acid, so that would sort of conduct electricity. Here's the most famous weak base, ammonia. The most famous weak acid, vinegar. Strong base, lithium hydroxide, absolutely conducts electricity. Sodium phosphate, a soluble salt, breaks up into a whole bunch of ions. There's 3 ions here, one more, total of 4 ions per unit. So that conducts, but I skipped one on purpose. Yeah, the alcohol here. The alcohol, the CH3OH, this oxygen bonded to that carbon forms a pretty strong bond, does not break up when you dissolve it in water. So alcohols are non-electrolytes. Not only do we care about electrolytes, but even as equally as important is trying to predict when a chemical reaction will happen, when a precipitation will happen. In doing so, we really need to memorize the solubility rules. If we know what is soluble, we know that it will dissolve in water and will not force a precipitation, or will not force undissolving, I call it. If we know what doesn't dissolve, similarly, we know what doesn't dissolve, what could possibly come together and form a precipitate. Here's one way to say it. Lithium salts, sodium salts, potassium salts, ammonium salts, even rubidium salts and cesium salts, first family salts, all dissolve in the water, always. Nitrates and acetates always dissolve. I say always, but for our purposes, always. All chlorides, bromides, iodides almost always dissolve in water, except for silver chloride, silver bromide, silver iodide, mercury 1 chloride, mercury 1 bromide, mercury 1 iodide, and lead bromide, lead iodide, lead chloride don't dissolve. So if I were to pour some lead ion water with some chloride ion water, they would mix and mingle and form a precipitation of lead chloride. Similarly, most sulfates dissolve in the water, although notable exceptions, again, silver and lead, calcium, strontium, barium sulfate don't dissolve in the water. Here's another way to say it. Not much different, but similar. Wait, is that redundant? I apologize. Sulfate salts mostly dissolve in the water. These don't. These salts dissolve in the water, except for these. All these salts, all these salts, all these salts, and all these salts dissolve in the water. Hate to say memorize, but the more you can remember, the better off you might be. They're important. Insoluble salts, as I've written it. Oh, goody. Oh well. I put the slide out of order. That's all right. We'll come back to a slide that has the same information, but hydroxides don't dissolve in water, except for the strong bases. Sulfides don't dissolve in water, except for ammonium sulfide, lithium, sodium, potassium, cesium, rubidium sulfide. Carbonates don't dissolve in the water, except for, again, the first family salts and ammonium carbonate. And the phosphates don't dissolve in the water, except for, again, lithium, sodium, potassium, cesium, rubidium, and ammonium phosphate do dissolve. Well, you're probably still scratching your head saying, how can you use this? Soluble salts always dissolve or dissociate, never force a precipitation. So sodium chloride always dissolves. Sodium chloride never comes together. It stays dissociated. Lithium nitrate always dissolves. turn it backwards. Lithium and nitrate never come together. No reaction. Will these force a precipitation? The answer is no. All these will not. Iron acetate always dissolves in the water. Turn it backwards. Will iron 2 plus come together with the acetate ion? No. Aluminum sulfate dissolves in water. Will it turn it backwards? Will aluminum ion and sulfate ion come together in the water? No reaction. Similarly, insoluble salts never dissolve. I guess it's the opposite, isn't it? Silver chloride solid never dissolves. Turn it backward. Will silver ion and chloride ion come together and undissolve themselves from the water? Yes, they will. Lead bromide, no dissociation. But so therefore the lead ion and the bromide ion in water will absolutely always come together. They collide with each other, they attract each other so strongly that the water can no longer hold them apart. Barium sulfate, no dissociation. Barium ion mixed with the sulfate ion in water will certainly form barium sulfate. Teeny particles of cloudy, moist barium sulfate that sink to the bottom of the beaker. Here are those insoluble ones rephrased again, if you want to look at them in this way. No matter how you slice it, you should try to remember as much of these as you can. So question, will sodium hydroxide come together in the water? No. In other words, turn it backwards, sodium hydroxide solid will always dissolve in the water. Iron hydroxide forms a precipitation. Turn it backwards, will iron hydroxide solid come apart in the water? No, it won't. It will not dissociate. How do I know this? I know that most hydroxides don't dissolve in the water, but sodium hydroxide does. Similarly for the sulfides. Most sulfides don't dissolve in the water, except for potassium sulfide. So potassium sulfide, no reaction. Potassium sulfide solid will not dissolve. Oh, well, yes, it will dissolve. Because I know most sulfides don't, like cadmium sulfide doesn't dissolve in the water. But if I turn it, the potassium, sodium, lithium, rubidium, ammonium salts do dissolve in the water. Most phosphates don't dissolve in the water. So magnesium phosphate, no reaction, no dissolving, or turn it backwards and they come together. But lithium salts do dissolve in the water, and there's no going backwards. Interesting. I wonder, oh shoot, there are the answers. Darn it, oh well. Most hydroxides don't dissolve in the water, except for the strong bases, so yes. Most bromides do dissolve in the water, except for silver, so no. Most calcium salts dissolve in the water, so yes, it will dissolve. Most nitrate salts dissolve in the water, so yes. Actually, all nitrate salts that I know of. Most sulfates dissolve in the water, except for lead. Lead sulfate doesn't dissolve in the water. Well, you could pause the video. Oh, you don't have to pause it, because I'm not going to give you the answer. You can hone your skills with these. Let's see. Oh, rats. No, I have given you the answer. Fiddlesticks. So will you see a precipitation or not? In the first one, yes, most carbonates don't dissolve in the water. So when the positive of the first meets the negative of the second, or it could possibly be, you might have to ask yourself, will the negative of the first meet the positive of the second? In this case, potassium and nitrate, all potassium salts and all nitrate salts dissolve in the water, so there's no reason for these two to come together. But there's a perfectly good reason for aluminum and carbonate to come together, because most carbonates don't dissolve in the water. So yes, I see a precipitation here. But silver acetate dissolves in the water and sodium nitrate dissolves in the water, so there's nothing going to happen here. Ammonium iodide dissolves in the water and copper sulfate dissolves in the water. So if I mix this beaker of water aqueous solution with this beaker of aqueous solution, nothing happens. And lastly, would lead chloride like to come together, or would iron acetate like to come together? The answers were yes and no respectively. All acetates dissolve in the water, so iron acetate does not come together. It stays floating around as spectators. But lead chloride does undissolve itself. Yeah, that's not a balanced equation, but I don't care. That wasn't the point. The point is what things dissolve, what things don't dissolve. Yeah, alright, Cool. Thanks for watching, guys. See you soon for better or for worse.